Right, hello. So, my name's Marc Gravell, and I'm going to be talking about designing a Redis client for humans. So, what does that mean? So, firstly, why am I talking about this? So, I work for Stack Overflow, and we use Redis hugely as one of our many backend services alongside SQL Server, Elastic, and a whole range of tools. We use whatever the right tool is for the job, and Redis is the right tool for a range of jobs. And we've been using that for the best part of a decade, pretty much since Redis has been readily available. And for a lot of that time, I've been in charge of dealing with how we actually talk to Redis. We initially used Miguel de Icaza's Redis bindings, but we found it wasn't a good fit for our usage, mostly for a lot of the reasons I'm going to be covering today, and to do with kind of complexity and the features available in Redis clients. And as a part of that mismatch, I ended up writing multiple Redis libraries. Initially, I wrote Booksleeve, and then more recently, StackExchange.redis, which is now part of Microsoft's ASP.NET Core All package. So it's used quite a lot to kind of provide access to things like Azure Redis, but also available widely on open source on NuGet and things. In fact, it's had about 9 million downloads now, so it gets a lot of use. I've also worked fairly closely with Redis Labs, Azure Cache, and various other people trying to make sure that the clients work well with Redis. So I've got a fairly good feel for a lot of the common issues that happen with clients, client libraries, dealing with end users and providers. So I've got a fairly good eye on all those different pieces, what clients want, what client libraries need to do, and what's happening on the server space, whether that's on-premises servers or cloud providers. And I have, because of Stack Overflow, we're pretty much a .NET C# shop. But that's not what I'm talking about today. Everything I'm talking about is going to be sort of common to all client libraries. So there's, in fact, one of the first times ever I've done a presentation, I don't think I've got a single piece of code on any slides. So yeah, don't worry about that. So that's pretty much where I'm coming from. So what do I want to do today? First thing I want to emphasize is, celebrate how well we're doing with Redis as a story. Users are succeeding with Redis. They're doing a great job, and they wouldn't be able to do that if client libraries weren't providing the features that they need. So, that's great, and I want to make fully acknowledge that. But that doesn't mean that we have to ignore where there are issues. So, part of what I want to do here is kind of identify a lot of the common themes of problems that happen with sort of Redis libraries, and see if we can kind of work towards improving that story. And I want to emphasize, I'm going to hold myself up for criticism here as well. This isn't my library's great, look at all these. Not at all. I know the failings in my libraries, and I'm not going to do any finger pointing to any kind of specific libraries, except my own. I'm trying to keep things kind of very positive, because it's doing well. One of the other things I want to do is, hopefully for this audience, I want to give a better understanding kind of what your Redis client library is already doing. You might be surprised the amount of things that are actually involved in writing a fully featured Redis library. And there's a lot of challenges involved in doing that. And maybe this can help show, particularly for end users, regular software developers, application software developers, why sometimes you might put in a feature request and thinking, this is a simple thing. Why hasn't the library author implemented that? Sometimes something that looks simple is actually much, much harder. So hopefully you can kind of get a better understanding of what's going on under the scenes, and maybe get a little more patience and sympathy towards the client library maintainers, who are usually working really hard and doing a great job, but they don't have all the time in the world. I also hope to, are there any client library developers in here today? Well, I know I could do better. Maybe we can kind of help spot each other and drive other client libraries to improve in the areas they're weak at, just as I hope to drive myself to improve the things that I could do better. And there's lots of people in this room. The reality is, most client libraries are open source and driven entirely by a relatively small number of maintainers. And maybe when you can see kind of some of the complexities and challenges that we're dealing with, maybe that can inspire some of you to kind of contribute towards the client library that you're using, whether it's PRs or anything else that can help, or even just bug reports are great to kind of help move that story forward. And also, server features. Maybe we've got Salvatore in the front here. If we can kind of be very open about kind of what some of the issues are with client libraries, that can help drive things forward. And I was really, really enthused with the keynote this morning, where Salvatore was kind of running through some of their plans there. And I think that he's kind of preempted me and completely destroyed some of my best slides, because it kind of looks like we're kind of already working in the right direction there. So that's good. So that's kind of some of the things I'm trying to cover today. So it should be simple, right? And it should be. It won't be a surprise. Redis is doing great. We're only in the second half of the first day here, unless you're here for the training. But I'm sure you've probably heard this plenty of times today, including in the keynotes. But so this is the 2018 developer survey. Redis is right at the top there. That's just awesome, and it shows that's based on 100,000 responses. That shows that not only is Redis an awesome server, but the client story can't be terrible. If it's the most loved Redis, most loved database tool, people need to be succeeding with it. So the client libraries must be fundamentally working, and that isn't isolated. You can also look at the year before, which was based on 64,000 responses. Very, very similar story. And that's as far back as we went with that question. So 2 for 2. That's great. So yeah, I absolutely trying to be very, very positive. And if anything I say sounds negative, it's not meant to be. I'm trying to take the success and move forward. So what else is going on? Redis is doing great. Most loved database. And it's got a really rich client ecosystem. I tried to have a look, try and get images for the presentation. And I tried to print out the screenshot of Redis client libraries. And when I tried printing it to PDF, because who's got a printer these days, it was 17 pages long, just the list of client libraries. So that's 175 client libraries covering 50 programming languages, and then on top of that, another 100 tools. And I know that list isn't complete because we've got a server tool, Observer, that we use at Stack Exchange, and it's also available on open source, and that isn't on the list. So that huge list is incomplete. There's even more than that. So if you want to work with Redis, there's a really good chance that a tool already exists for your platform, especially if what you're after is kind of the common scenarios. So it's also a really good server ecosystem. So you've got the Redis on-prem, the open source product, but there's also multiple providers making Redis available on the cloud. You've got Redis Labs, obviously. You've got Amazon, various others that I've kind of worked with or seen other people working with, and having success. So that's a really good indication that it's doing great. And the server features. Everyone knows that you saw in the keynote earlier where it started off as everyone thought of it as a cache, but now I know Redis Labs really kind of keen to push it as a I think multimodal database. Is that the something like that? But it's a really rich product with tons of great features, and it's always ever increasing, as we saw earlier. And with Redis modules as well, it's literally limitless what you can do with a server. So all in all, it's looking great. So great that I tried looking for it, and it turns out Redis is trying to have its cake and eat it. That's from one of the previous Redis conferences. It's amazing what crazy things show up on Google. But there's always a but. It would be a really short session otherwise. So I'm trying to kind of look at where client libraries can do better. So what are the common problems? basically, there's a huge, in that 175 set list of client libraries, there's a huge variation in the quality and the features that are available. The actual core Redis API is deceptively simple. You can knock out a Redis client in an afternoon if you're just trying to talk various simple commands, client to server. I've done it several times for various demonstrations or for experimental code. But it starts breaking down really quickly as soon as you move past the those simple scenarios, which I'm kind of going to cover in a moment. So it turns out that just sending a single command to Redis and getting a reply back, that's just the very, very thin end of a very wide wedge. Very wide wedge. So rhetorical. But what is the single biggest reason for client libraries to be incomplete or have this variation? Squirrel. So client library authors are often trying to solve a problem. They're not trying to write a client library that does a perfect job of something. They're trying to solve their immediate business need, and then when they've done that, that's it. They've got other problems to solve. So they come in, they can't find a tool that does what they want, so they implement it or add a small extension to an existing one, and then they move on. And who can blame them? It's almost impossible to design and test for features that you aren't using. That's actually one of the reasons why Stack Exchange.Redis at the moment doesn't implement Sentinel support. There's actually an open pull request for Sentinel support in our client library, and I really do need to dig out the time to kind of evaluate it, but I'm not an expert on Sentinel, and it's really hard for me as a library author to kind of judge that PR and say, is that solving the right problem? Is it solving it well? Has it thought out all the edge conditions for a feature that I'm not using? And that's kind of, I think, is a common theme for a range of these features. Yeah. The other thing is, client library authors move on, as I said. Their job changes, or they move to the next employer, or maybe they've left the industry completely, or actually passed on. With 175 libraries and 10 years of development, it's a reality. And many of the libraries, like I said, are free and open source. So that makes it very, very likely that things are going to be in that state. In some ways, a small part of me sees the wisdom of some of the sort of the paid libraries, like Service Stack, but I kind of really stand behind the free open source side of things. But it is hard work keeping all that stuff together without a body to kind of keep over it. It's actually one of the reasons why we haven't confirmed anything yet, but we're trying to move Stack Exchange.Redis into the .NET Foundation, which is kind of a supervisory body or an assistance body that can kind of provide some level of stewardship and sort of progression planning. Should the current maintainers move on with the project, it means that they have then got the ability to take over the project and make sure that it moves forward for the community. So yeah, that's that. And server features keep changing. I don't mean that in a negative thing. I love the server features that have come into Redis. But there is a lot of complexity, and it changes. Redis today is almost unrecognizable from where it was when I started using it. It's almost a completely different product. And some of those changes that have come along the way kind of fundamentally change the shape of the clients. And I'll come on to these in more detail later. Sometimes they might be able to fit a feature into an existing library, but sometimes it might need quite a massive overhaul or even a rewrite from scratch to get a library to work with some of the Redis features. Although it sounds like Salvatore's got a pragmatic solution for some of those things, which I'll come on to later. And consumer expectations change. Programming is never a static playing field, unless you're using C. So in some technologies, the demands of the consumer changes radically. So for me, the big one there in .NET was the introduction of async. So if you were in Jim Nelson's talk earlier, in .NET, async maps very closely to the kind of the futures and promises example that he was talking about there. And I know there's a very similar thing in kind of most programming languages. But to do that, truly to do kind of async all the way down to the network and back in .NET, you kind of need to rewrite the code completely to be async all the way. You can't kind of hack async into an existing synchronous system. It just doesn't work like that, at least not in .NET. So sometimes what looks like a really simple PR, like, hey, just add an async API, that can just represent a soul-destroying amount of work. There we go. So, Redis client. It is hugely tempting to think of a Redis client as that. There you go. You've got one bit of software that talks over a TCP socket to a Redis server. How hard can that be? Oh. So that would be nice, but that's just not how it works at all. First thing that goes on is you probably don't want one connection. You probably need two, because or at least two. Because if you're using PubSub, they're actually two different, completely different. Well, I say completely different. They have fundamentally different behaviors, the two different protocols. The kind of the request response protocol works one way, and then there's a PubSub protocol that works, quite differently. So they need to have very different designs, and so you need a separate connection for that, really. Key space notification, for example, works on PubSub, and that ties into things like cache expiration if you're using things like that. So an awful lot of libraries will need to talk things like PubSub. And then somebody comes along and introduces replication, or in Redis terminology, master slave. And you might think, oh, I can just talk to the master. That'll have the current truth, but you might need to share your CPU cycles. You might want to talk to the slave for expensive read operations that don't actually need to be, they don't need to have the absolute truth, they just need to be truth enough. So if you talk to the slave, you might be a couple of milliseconds out, but you're going to get a great response. Or if you want to do analysis things, such as key space analysis, so you want to run scan and analyze your keys, you're going to want to talk to the slave. And from a client library perspective, there's all sorts of interesting things. Like if somebody then comes along and decides to change the topology, you don't actually get, and there's nothing in Redis that then talks back to the client and says, oh, by the way, the configuration's changed, you need to go and think on that. So the client libraries need to kind of manage that themselves manually and keep an eye on kind of what's happening. So, replication in Redis can be much more complicated. Now you've got multiple slaves, a single master, each with two connections probably, and you might want to round robin the actual work that you're doing across multiple slaves, especially for those expensive read operations. So you see all of a sudden the amount of things that your client library is doing is kind of increasing even more. Then somebody adds Sentinel. So Sentinel, if you're not familiar with it, is technology that basically allows a couple of servers, Redis servers on one side, to monitor what's happening in the actual cluster server nodes and respond for fault tolerance. For example, it could change the master-slave designation. Or you can also use it as service discovery. So a common scenario is to configure the client to point at the Sentinel and give it a service name. So then the client goes to the Sentinel and says, where's this service? The Sentinel tells it where it is, and then the client connects over there. So the client doesn't actually know where the Redis servers are in advance. So it's yet another set of things that the library might need to do. And of course, talking to a server is one at a time is limiting, and most consumers these days are massively parallel. You're talking about web farms, web servers, things like that, where you haven't got one request going on concurrently. You've actually got 60 requests or 200 requests or whatever your loading factor is on your servers. So then your Redis client library is going to have to provide some mechanism of that, because you don't want to spin up a Redis connection for every HTTP request that comes into your web server, do something and then spin it down. There's a lot of work that goes on when you talk to Redis initially to configure it and discover the configuration and topology. So instead, your library is going to have to either expose some kind of lease API to allow you to lease a connection from a pool of already available Redis connections, or it's going to have to do some kind of multiplexing to have one or a small number of connections to Redis, and then take these 200 parallel requests and split the requests down those small number of pipes, and then get the responses back and spit them back to the correct callers. So it's another set of kind of complex things that might have to be going on in the background. And networks are not stable. So as soon as your client library is more than one TCP socket, your consumers are probably going to expect some level of at least detection or presumably recovery from network failures. And not only are sockets unreliable, but socket failure detection is unreliable. The only way to reliably detect a broken TCP socket is to send a message and get a response. If you can't send a message and get a response, the socket's broken. That's the only way you can truly detect a broken socket. But it isn't just enough to reconnect. You can't just connect back to that server. Take PubSub, for example. All of a sudden, you've just connected back to the server that you disconnected from. Now you need to remember all the 200 things that your client, your calling application code, had previously subscribed to. And you're going to have to resubscribe on that other connection. So there's all sorts of things that are going on. And what should you do with requests that fail while that socket's down? Should you resend them? How many times should you resend them? Should you send some commands but not others? A set command, that's probably safe to resend because it's not going to change something in a bad way. Either it gets through or it won't. The value is still what you want it to be. But an incre command that increments a counter, if you send it 10 times because you weren't sure, that might have got through 0 times. It might have got through all 10 times. So there's a lot of complex decisions that you need to make as a kind of a library author in terms of what you actually do around broken connections. And this is just the raw socket topology. There's a whole load of other things that are going on that make it more complex. So what else is happening? Well, at a simple level, the server may or may not have security configured. You'd be surprised how many client libraries don't have that built in automatically because the original author, they weren't using auth. That's becoming less now, especially after the problems we had with Redis servers on the public internet a while ago, and somebody wrote a script that went through and locked them. That was a fun one. I hope none of you got bit by that. But it's just one more thing that an author might not have needed. And then there's all the configuration things that the client library has to talk to the server and find out when it's connecting. Is it a server? Is this server a master or a slave? How many databases does it have? So if somebody tries to access database 200 and you've only got 10 configured, can that fail at the client? Are key space notifications enabled? All sorts of things that it needs to find out if the commands are available. And the server version. Different Redis server versions have had very different capabilities built in. And depending on the type of Redis client that you're using, sometimes a client library is just, you give me the command, I'll run it. But sometimes some client libraries try and offer a bit more kind of management. So they do a bit more thinking in terms of how best to optimize things. For example, should it use keys or should it use the scan functionality, which is has less, scan has more round trips, but has less impact in terms of crunching the CPU all in one big go. Can it use the EX-PX modifiers on set? Or does it have to use expire? Is the hash delete command, HDEL, is that sporadic, or does it have to issue 10 HDEL commands in a multi-exec? So there's loads of things that it might need to know the server version for. One of the more interesting features in Redis, it's very rare in other systems, is the ability to actually rewrite the command names. And that's something that I know a lot of cloud providers do to stop people accessing the config command because they don't want people doing config set and changing how the server's configured. Or they might disable the debug command, for example, because debug segfault, which is always a fun one to run. Or if you're using on-prem, you might rename, keys to fire me or something, You'd be amazed how many outages keys has caused. It's always a fun one. So you can decide whether the calling code needs to know that or whether it's part of the library, but it's just one more set of things. And I'll come on to some other reasons in a moment why I think it's much better for client libraries to know about the commands and the command renaming map, which I'll show you in a second. So what else? PubSub management. So like I mentioned earlier, if you're doing pub/sub, the calling code is going to have to subscribe to multiple different channels, and it's going to have to manage, keep a lookup somewhere of, so you've subscribed to 200 different channels, and some of them might be wildcards. Somewhere it's going to have to keep those dictionaries, and then when things come in off the pub/sub pipe, it's going to have to dispatch those to the right caller. So that's a lot more management. And binary safe keys and values. For some frameworks, providing this feature is nice and simple. So if you don't know, in Redis, the key names don't have to be strings. Your key name can be random bytes. Values are probably more common as bytes, because then you can do things like message pack or protobuf, or a raw PDF document. Whatever we want to store in Redis, it's fine. It doesn't care. But in some frameworks, Java, for example, so not Java, JavaScript, it's remarkably hard to talk in raw bytes, because the actual language itself doesn't make that easy. So it's one more set of things that might be more complicated to do, especially if your client library is actually sharing a Redis server between kind of different technology stacks, and the existing codes use binary, and your new framework doesn't really kind of have that as a metaphor. And script management. Lua is great. If you've ever used the multi-exec watch approach for trying to perform an atomic operation on Redis, you can do it, but it's painful. It's very hard to get it right. And even if you do get it right, you have to pay the bandwidth cost and the latency cost of getting messages for however many operations you need to do to figure out what your code needs to do. You need to pay that. Whereas in Lua, you can send all that stuff down to the server, have it execute on the server, and it's great. But even client libraries probably need to worry about script management, because there's two ways of issuing Lua. You've got eval and you've got eval SHA. And at any point, some other piece of code could do a script flush. So your client library, if it's going to be friendly to the consumers, it's probably going to need to kind of compensate for a lot of things there. It's going to have to know which things have been loaded and know how to recover if it gets a script failure message. So even these things add complexity. And then TLS. I love TLS. So this is huge on cloud providers, obviously, where you're going over the public internet. But even on a protected subnet, secure communications can be essential. Whether that could be just to protect your auth details, but it could be a compliance requirement for some kind of legal process. But TLS is not currently in the core Redis server. You can use stunnel or stunnel, or all those kind of tools to kind of create a secure pipe to talk to Redis to from libraries. But then you get into the situation where it's very hard as a library consumer, an app developer, to say, I just want to know, here's the Redis details that I need to know. Now, I'm renting this server. I can't configure it. I'm just a cloud function. I just want to know the Redis details and have it talk to the server. And that's very hard to do if your client library doesn't support TLS, and your client library at the moment is unlikely to support TLS because the server doesn't support TLS. But I was very delighted to see in the last week this PR come in from Madeline Olson. So obviously I'm not in charge of whether that gets merged, but I think it's one of those things that would kind of really help kind of standardize the client offering in terms of kind of security. But yeah, it does exist, and I'm not the only person who it bothers. So well done, Madeline. So that's a lot of stuff that's going on, and then that's just regular kind of Redis server, and then somebody comes along and says, "Hey, there's this cluster thing. We should do that. That's the new big noise." So what does that do to the topology? All of a sudden, we go from this to this, and there is no way I could actually fit all the lines on here to show what's talking to what in Redis cluster. if you can link two boxes, there probably needs to be at least one line there. So the pale blue chunk is what thinks of itself as a Redis cluster. And your library is probably going to want to talk to all of them. So that could be because it's trying to share load between the slaves for expensive reads. And you certainly need to talk to all the masters, because the whole point of the way that Redis cluster works is that it takes the key space, so all the names that you could think up as keys, and divides them into 16,000 odd slots. And then it shards those slots between different kind of sets of cluster nodes. And there's an algorithm you can run, a documented algorithm, to any key that you can think of that will basically give you that number between 16,384. It's tell you which slot it is. Now, long before Redis cluster arrived, you could do sharding with twem proxy, which acts as a single box that pretends to be Redis and kind of sits in front of all those shards. And that made it really easy, and regular old school Redis clients, they just needed to know the twem proxy address. They talk to twem proxy, and twem proxy talks to all the Redis servers. It's simple. It didn't work with all commands by any stretch, and there were lots of things it can't do. But for Redis client libraries, it was a very, very simple way of talking to a sharded system. Redis cluster is not at all like twem proxy. So when you've got a command coming in, you need to look at the keys that you know that you've been told to issue the command against, run that algorithm, figure out what slot it's in, then figure out which shard it's in, and send it to the right server. And this is actually one of the big areas, I think, where client libraries have diverged over the last few years. There's three camps when it comes to Redis cluster. Camp one says, sure, I can load the shard map from the server, I can understand your commands, and I can route things to the right server. I got this. Camp 2 says, that's kind of hard. I'll tell you what, I'll talk to one server, and if it says moved, I'll talk to another server, and I'll stay down here for a bit. And then, so basically it's just bouncing between servers, listening for moved commands, and then talking to others. And I found several libraries that work this way, because the original implement... Sorry?
Can you name names?
I'm not going to name names, no. Not here. That's hugely problematic, as you can understand. I think the minimum number of nodes in a cluster is 3. So that means you're already more likely to be wrong than you are to be right, if you're using that kind of approach. And there's obviously performance implications if you're going to be doing essentially a page fault for most of your operations. That's painful. And the third camp just says, no, and says, that's not my problem. I'll just talk to a server. Everything else is yours. So yeah, there's a lot of problems there. But I was delighted in Salvatore's keynote today to hear that one of the ideas that they're talking about for kind of what happens next is the idea of some kind of essentially cluster proxy that sits in front of the boxes. Now, if I've understood that right, and I heard it for the first time this morning, then I think that's sort of a very pragmatic way that could help correct the path there, especially for client libraries that aren't going to find it easy to kind of adopt to cluster. But like I say, I only heard about that today, and I'm really excited to hear what the story is there, and it might be that I completely misunderstood it, and that isn't kind of what's going on at all. But the other problem is that to do that sharding algorithm, you need to understand your commands, because you need to understand you've got this some kind of weird set of instructions that say do this operation on these keys with these values. You need to understand exactly which ones of those are keys, which ones are subcommands, which ones are values, because you only need to do the sharding algorithm on the keys. Now there is a command you can use to find out what your commands structure is. It's the command, I think. But that, again, it's one more thing that client libraries would need to do in order to kind of implement this type of system. And indeed, a fun nuance that I found out a while ago, I hadn't realized before, key space notifications on cluster don't replicate. So normally on PubSub, you can connect to any node, and the messages replicate to all other nodes, so it doesn't matter where you connect, you just get it. Key space notifications only get sent from the node that's actually doing the key space change. So client libraries need to know about that as well and understand all those complex rules. And then in 4.0, modules came along. Modules are great. If you saw the demos in the keynote, there are some really stunning things that you can do in Redis modules with the search, the machine learning, all those things. Really, really powerful. But a lot of times they introduce new client semantics because if I take, say, the Redis search, it's such a complex tool that you're going to want, you're not going to want, most clients aren't going to just want to have to send raw commands. They're going to want some kind of structured API. So you're going to have to, your client library is going to have some way of kind of exposing these new features. And it needs to understand those key semantics, again, that I just covered. Now, and the command names can be arbitrary. That might not be something your client library handles. It's all these kind of complications. And you need to understand, again, which parameters are keys. So I think there's a huge amount of kind of complications there. The modules one is probably quite an easy one for most libraries, but there are still kind of various challenges that people need to kind of consider. So if you're at the keynote this morning, like I said earlier, there's a lot of interesting things that I kind of saw there. The cluster proxy, I think, sounds, if I've understood it, sounds like a kind of a great tool for kind of moving things forward in terms of, because the issue is that a lot of clients just don't do clustering well at the moment. And he also mentioned a possibility of a new single connection that could service both PubSub style and request response style APIs. So that would be useful in terms of, again, cutting down the number of connections. So I believe you mentioned that in connection to the L1, L2 kind of caching scenario. Again, that again would require more client library changes for people to implement that, but I think it's a really kind of interesting feature for network efficiency. And again, the L1, L2 cache itself would require client library support, but that is such a common scenario. I want to use Redis as a cache, and I want to do caching up here, and previously I've been using PubSub as my caching validation. So if that happens, I can foresee that would be something that a lot of Redis client libraries would want to kind of adopt. So yeah. So what point am I trying to get at with all of this? Different clients provide wildly different solutions, and they provide solutions to different subsets of all these different features. Some of them are great at some and weak at others. Some might not do some of the features at all. Myself and Sentinel at the moment, we need to fix it. But if you're a client library consumer, you're thinking that's not my problem. I just want a client library that works. And at the moment, it's very hard to know which features are available on each. So in Jim's session earlier, some of the questions that came up, I think at least 3 of them were, can you do that with Java? Can you do that with JavaScript? And fair enough, it's not his area. He didn't know, but I think if you went to the client libraries list at the moment, you also wouldn't know. It's very hard to know which client libraries to provide which features. So what I would love to see for us as a library, as a community rather, of library users and library authors is to collectively think about whether we can kind of put together a feature matrix of what we think the key features are for Redis clients. And basically see if we can get to a point where we can replace the current client list, which is just kind of a very, very flat introduction into all these 175 client libraries, and actually kind of break it down at a glance with what features each library supports. So as a consumer, you can see at a glance what features they support. Also, developers are competitive. So if you're there and you can see where the gaps are on your library, that might help either yourself as a maintainer or external people with kind of PRs and contributors to come in and plug those gaps, and at least we can have an honest discussion about what's doing what. So yeah, feature matrix. So we can actually get very clear visibility, encourage people. Problem is filling those 175 rows, if that was kind of something we could do. But then if a library sits there and hasn't actually touched, if we did have this matrix and nobody had come along and said, yes, I implement this, this, and this, possibly says something after, say, a year as to the state of that library and the usage of it. So maybe that by itself is actually, kind of very revealing. Maybe we could even do something with performance data, although that's a much more complicated problem. So, good for everyone. What I'd really love to do, I'd love to have a conversation with Salvatore about this, is kind of move from this at the moment, and these libraries are chosen purely at random. There's nothing meaningful about the choice there, to something kind of more like this, where we can kind of understand which libraries do what. So, summary, Redis is really complicated, and I hope you can perhaps understand that a bit more as kind of, certainly as library consumers, that it isn't necessarily, the library is probably doing a lot more than most people expect. And really just kind of, if you are a library author and contributor, thank you. I know it's hard work. It just is. And if you're a library consumer, be gentle with us. We are trying. And I love where things are, but I think we can do even better. So, that's me. Are there any questions? Salvatore.
Yes.
Hang on, wait for the mic.
I really like the idea of the metrics for the client features, and now there is a new person that works with me just to the open source, which is Fabio, which is the guy that ported Redis trib to the Redis CLI, and he is a very good Ruby developer, so he can change the site, the website. So this is the perfect moment to implement something like that. And I was thinking that probably what do you think if, for example, that now clients are described by the JSON file, we could assign like a small tag for each feature.
Yeah.
And also I wanted to tell something that Dvir thought, which was what about in the matrix introducing the idea of different levels of clients. Like client level 1 is just command and reply.
Yeah, so a minimum feature set that you need to...
exactly,
yeah.
so to standardize a bit. And also I wanted to ask you if you believe that the proxy, the cluster proxy, should also perhaps works also in order to support the Sentinel protocol, or if Sentinel is easy enough that it's better to leave basically on the client side.
So I think the first part of that, I'm not sure it's a question, but it sounds like you're all in favor of it, so that sounds good, and I'd love to work with you guys and happily contribute my thoughts towards what some of those things that should be in the matrix. But I'm pretty sure, based on the things you were saying in the keynote, I think you kind of understand what's going on there. So the second bit about Sentinel, I'm probably not the right person to ask, but that would seem to provide a simple mechanism to support Sentinel in a wide range of cases. But I'm kind of thinking on my feet here. I don't really know. You've probably got a much better idea on that than me, to be honest.
Thanks.
Okay. Any other questions?
It looks like we're all set. Thank you very much, Mark. Really appreciate it.
Thank you.